Hello, so today we'll be looking at quadratic equations, and previously we have studied polynomials, which are polynomial in X is simply an expression of the form A0 plus A1X plus A2X to the 2 all the way to ANX to the N, where N is a natural number or a positive integer. And so this is a polynomial in X. You can also refer to it as an expression in X. So when the order is 2, when you have an expression like f of X, let's say A0 plus A1X plus A2X squared, this is a quadratic polynomial. Quadratic polynomial. Some people refer to this as quadratic expression. Quadratic expression. Now, when you introduce an equality from this expression, you get a quadratic equation. So an example of quadratic equation is A0 plus A1X plus A2X squared is, let's say, B. This is an example of a quadratic equation. We have introduced the equality symbol. Now, in general, we'll be studying equations of the form AX squared plus BX plus C is equal to 0. But before this, let me give you examples of quadratic equations. An example of quadratic equation is, let's say, x squared plus 2x plus 1 is equal to 0. This is an example of a quadratic equation. Now, a quadratic equation, a quadratic expression will take some variables and give you an output. So for example, this one takes some variables x and gives you an output 0. Suppose you pick x is equal to 5, x is equal to 5. Then you'll have 5 squared plus 2 times 5 plus 1. This gives you 25 plus 10, that's 35, plus this is 36, which is not equal to 0. So that means 5 does not satisfy this equation. Equations which satisfy, the values which satisfy this equation, which if you put here, you get a 0, will be referred to as roots or zeros or solutions of the quadratic equation. Zeros because when you plug them in the equation, you get a 0. So let's see how to get zeros of a quadratic equation. Zeros of a quadratic equation. Zeros of quadratic equation. You can also refer to them as roots. So before we see how to get roots or results of a quadratic equation, let me give you a quadratic equation and its roots. The previous example that I gave, x squared plus 2x plus 1 is equal to 0. If you choose x is equal to -1, let x be equal to -1 and put it in this equation, then you will have -1 squared plus 2 times -1 plus 1. This gives you 1 minus 2 plus 1, which is effectively 0. So we will say that 1 is a 0 of the equation x squared plus 2x plus 1. 1 is a 0 because if you plug it into this equation, you obtain a 0. So now the big question is, now that we know what zeros or roots of equations are, how do you obtain roots or zeros of equation? Recall, previously we have studied equations of the form x to the n is equal to a, x to the n is equal to a. In particular, and n to be 2, x to the 2 is equal to a. To solve the first equation, so this is the first equation, second equation, solve the first equation, simply find the nth roots on both sides. So solution to the first equation is that x will be the nth root of a, which is simply a raised to the 1 over n. Similarly, the solution to the second equation will be the second root, which is essentially the square root. So you will put here x is the square root of a. This will be a 0 of this equation. 0 of this equation because we can write x squared is equal to a as x squared minus a is equal to 0. So suppose I put root of a into this expression, the equation, I will put root of a squared that gives you a minus a is a 0. So any root of an equation can also be referred to as a 0 of the equation. Now let's look at some 3 methods that we will learn to use to obtain roots or zeros of an equation. So we look at 3 methods. Number 1 is factorization. We did factorization before. The second method would be completing the square. Completing the square. And the last method would be quadratic formula. Quadratic formula, which is essentially using the completing square method to derive a formula which you can use to solve quadratic equations. So you just plug in values from the equation and you obtain the zeros of the equation. Factorization. So number 1, factorization. Factorization. We learned before that in general, to factorize an expression of the form ax squared plus bx plus c. To factorize this, you simply need to write this as a product of some linear polynomials or first order polynomials. So we're looking for an expression of the form maybe x plus p times x plus q, where p and q are real numbers. We said that in general, to factorize that kind of an expression, you simply take, you look for 2 numbers whose sum is b and product is ac. So in other words, take the coefficient of the x squared multiplied by the constant term. So the 2 numbers should have that product, and then the coefficient of the linear variable x, b. So they should have a sum b. This is how we factorize quadratic expressions in general. So example, let's say you have x squared plus 6x plus 9. Factorize this quadratic expression. So in this case, b is 6, so I need to look for 2 numbers whose sum is 6, and the product must be 9, where 9 I obtained by taking 9 times 1. Well, 3 and 3 will satisfy this requirement. So 3 plus 3 is 6, and 3 times 3 is 9. So then you write that x squared plus, so I can write 6x as 3x plus 3x, because the sum of 3 and 3 is 6. So instead of writing 6x, I write 3x plus 3x and then plus 9. I'm doing that because 6 is the same as 3 plus 3. Therefore, 6x will be 3x plus 3x. And now I need to group these terms. Group the terms. After grouping, then we can now pull out the common terms. So in x squared and 3x, x is common. So I pull out x into x plus 3. So how I obtain x is that x squared divided by x gives you x. 3x divided by x gives you 3. Plus the common term in 3x and 9 is simply 3. So I pull out 3 into x plus 3, because 3 divides 3x x times, 3 divides 9 3 times. So we have again x plus 3 is a common term. Pull out x plus 3. So we have x plus 3 outside into, in the first group we have x, in the second group we have 3. So that means the expression x squared plus 6x plus 9 can be factored as x plus 3 times x plus 3. Remember, x plus 3 and x plus 3 are linear. So in this case, p and q will simply be 3 and 3. Cool. Now that we have revised factorization, how do we use factorization to solve quadratic equations? And we're going to use properties of real numbers, or what the so-called integral domain. So integral domain is simply a set of numbers for which the product of any two numbers is zero if and only if one of those numbers is zero. So the property we will use, is that AB is zero if and only if A is zero or B is zero. So for example, 2 times 0 is 0. In this case, 2 is not 0, but 0 is 0, so the product is 0. So what this property tells you that you cannot multiply 2 and 0 terms and obtain a 0. One of the numbers has to be 0. So for example, there is no way 2 times 3 can be equal to 0. It can never be equal to 0 because none of them is a 0. It is this property which we use to solve quadratic expressions, which can be factored. Remember, not all quadratic expressions can be factored. Not all of them will be, susceptible to this kind of manipulation. So I will use this example that we have. We want to, so first of all, let me give you a general idea. So in general, if you can factorize ax squared plus bx plus c is equal to 0, which is now a quadratic equation. So if I move the equality, it's a quadratic expression. But if I put the equality, it's a quadratic equation. Remember, we know how to factorize this part, this expression. So suppose it can be factored as x plus p times x plus q is equal to 0. This is the property we are using. So let A be the first in the first bracket, B be in the second bracket. The property tells you that the only way this can be 0 is if either x plus p is 0 or x plus q is 0. So from the property, I've picked either A is 0 or B is 0. But from x plus p is 0, you get that x is equal to minus p. It's a linear equation, which is very easy to solve. And from x plus q is 0, you get that x is minus q. So in general, the zeros of this equation will be minus p and minus q. And we know that by the fundamental theorem of algebra, we expect two solutions to a quadratic expression. Okay, so the example that we can factorize x squared plus 6x plus 9, an expression, if you make this an equation, then we know that x squared plus 6x plus 9 factors are x plus 3 times x plus 3. So take x plus 3, x plus 3 is equal to 0. Now, by the property of real numbers, integral domains, that the product of two numbers is 0 if and only if one of them is 0, tells you that x plus 3 will be 0 or x plus 3 will be 0. Therefore, x is minus 3 and x is minus 3. So in this case, we have found a solution which is repeated twice. And there's no problem with that. It can happen. So because x plus 3 times x plus 3 is 0, either x is minus 3 or x is minus 3. This is an example, an equation with repeated roots. So fundamental theorem of algebra tells you that for quadratic expression, we expect at most two solutions. Let me give another example of quadratic equation, which can be solved, which we will solve by factorization. For another example, suppose you have x squared minus 2x plus 1 is equal to 0. Equation solved by factorization. So if you're asked to solve, the question is simply asking you to find the zeros of this expression. Find me an x such that if I substitute in this equation, it will be true. In other words, the left-hand side will be 0. Cool. So first, factorize. So factorize. So step number 1, factorize the left-hand side. The left-hand side, I need to look for two terms whose sum is -2 and product is 1. So the trick here is to normally find how to factorize the product and only pick the factors whose sum is -2. I mean, the factors of 1 could be -1, 1, a half, and 2, a third times 3. But in this case, if I took -1 and -1, it's obvious that -1 times -1 is 1, because a negative times a negative gives you a positive, and -1 minus 1 is -2. So these two terms, two factors, -1 and -1, will help us here. So I can write -2 as -1 minus 1. Therefore, x squared, so instead of -2x, I want to write -2 as -1 minus 1. So I will have -x plus 1 is equal to 0. Good, so you need to group these terms. So you need to group them. So x squared minus x plus 1 is equal to 0. This is your first group. Second group, then pull out the common term. In the first group, x is common. So x goes into x times, and you do x squared x times into -x minus 1 times minus. So in minus x and 1, there's only one common term, which is -1. So -1 goes into x times, it goes into 1, -1 times, is equal to 0. Then I need to pull out x plus 1, which is a common term. So I have x plus 1, the first group, x, the second group, -1 is equal to 0. So by the property of real numbers, this product can be 0 if and only if one of these terms is 0. So either x minus 1 is 0 or x minus 1 is 0, which tells you that x is 1 or x is 1. So in this case, you have two repeated roots, 1 and 1. So this tells you that the solution to this expression is 1. If you put 1 here, you will get a 0. So if I put 1, so the 1 squared is 1, 2 times 1 is 2. So 1 minus 2 plus 1 is 0. So 1 solves this equation. The beauty about this quadratic equation is that once you found a 0, you can always substitute it back into the equation and see if it is really a 0. So this is how we solve quadratic equations by factorization. Okay. Factorize the left-hand side, then use the property of real numbers that the product of two numbers is 0 if and only if one of those numbers is 0. This way you obtain linear equations, which are very easy to solve. The next method that I want us to learn is called completing the square. The method of completing the square. Recall that we know how to solve expressions like x squared is 4 from our general study of the exponents, where we had x to the n is a. You can solve this as x is the nth root of a, which is simply a raised to the power 1 over n. The same way to solve this, I will simply need to take square roots on both sides. So I will take x is equal to plus or minus square root of 4, which gives me -2 or +2. So if I put either 2 or -2, we'll solve this quadratic equation. Such kind of equations, the left-hand side is called a perfect square. So in general, expressions like x plus or minus b squared is equal to c, the left-hand side is called a square, and perfect square is called a perfect square. And solution of quadratic equations in which the left-hand side or the right-hand side is a perfect square is pretty easy. Find square roots of both sides, the left-hand side and the right-hand side. So to solve this, I just need to find square roots of both sides, so that x plus or minus b is going to be plus or minus square root of c. Okay, and therefore x is going to be minus or plus b plus or minus square root of c. But the problem we have is that not all quadratic equations are perfect squares as they're given. So the first thing you need to do is to be able to write the quadratic equation as a perfect square. And this is something we can do in general. We can write any quadratic equation as a perfect square. So what that means is that given any quadratic equation, ax squared plus bx plus c is 0, our aim is to be able to find some way of writing this as, let's say, x plus maybe p divided by q squared. This is our main interest. We are interested in writing this expression as a perfect square. Now, suppose a is not 0, so we can divide by 0. And in case a is 0, then you don't have a quadratic equation. So a must not be 0. Then I can divide both sides of this equation by a. So I will have x squared plus b over ax plus c equal to 0. Okay. So x squared plus b over ax plus actually c over a. So let b over a, I want to avoid fractions, let that be k, let c over a be something s. So we have x squared plus kx plus s is equal to 0. I want to write the left hand side as a perfect square. Okay, so I need to be able to write this as something like x plus, I don't know, maybe let me call it h squared. So in other words, I need x squared plus kx plus s should be, when you expand this, so this is the same as x plus h times x plus n, the reverse of factorization, which will give you x squared plus 2xh plus h squared. Now equate both terms. So equate the higher order, equate terms of the same degree. So I will equate x squared to x squared, because that's the only way these expressions can be equal. I will equate kx to 2xh, and I will equate s to h squared. So this means k has to be equal to 2h. K is the coefficient of x this side, 2h is the coefficient of x this side. S is the constant term, h squared is the constant term, so s must be h squared. But what was k? K was b divided by a. And what was h? What was s? Sorry, s was c divided by a. So this means from here we can actually obtain. So this is k is equal to 2h, which is b divided by a. I can obtain h from here in terms of k. So this means h is going to be k divided by 2, which has to be b divided by 2a, because k is simply b divided by a. So k divided by 2 will be b divided by 2a. And therefore, we have h as k divided by 2. But remember, h squared is going to be s. So therefore, h squared will be b divided by 2a squared. Cool. So in general, factorize the quadratic equation of the form ax squared plus bx plus c. To write this as a perfect square, this is simply going to be x plus h squared. But we have x plus, what's h? H is b divided by 2a. So this should be h divided by 2a squared. Let's take an example of how to complete the square. So how to complete the square, you simply need to add b divided by 2a squared. This is what you need to add, this s, b divided by 2a squared. Example, First of all, let us complete squares before we use them. Complete the square. In general, to complete the square on ax squared plus bx plus c is equal to 0, you simply add half. So first thing is to make the coefficient of x squared 1. So you write this as x squared plus b divided by 2. So b divided by ax is minus c divided by a, and then add half of this squared, and then add x squared plus b divided by a, b divided by a, x plus b divided by 2a squared should be equal to minus c plus, so I add on both sides the same term. For me to maintain the meaning of the expression, I need to add what I add on the left hand side, I should add on the right hand side. Let me give a concrete example. Complete the squares in the following expressions. So I'll give very simple examples. So let's say you have x squared plus 2x. Complete the square. In this case, the coefficient of x squared is 1, so we're good to go. Coefficient of x, which is now b, is 2. So to complete a square, you need to add b divided by 2a squared. In this case, a is 1, b is 2. So I should add 2 divided by 2 squared, which is 1. So we'll add 1. So x squared plus 2x. If I add 1, this should give me x plus 1 squared. Remember this formula, it should become x plus b divided by 2a squared. So in this case, b divided by 2a squared turns out to be 1. So this should give me x plus 1 squared. When I complete the square by adding b divided by 2a, this can be x plus 1 squared. So suppose I was to solve this kind of a quadratic expression, then I would simply need to get this to 0 and then use the property of real numbers, that the product of two real numbers is 0 even only if one of them is 0. Example 2, complete the square on x squared plus, I don't know, maybe square root of 5x. Complete the square. The trick is very simple. So in this case, a is 1, b is square root of 5, because c is 0. So to complete the square, add b divided by 2a squared. So we need to have x squared plus square root of 5x plus square root of 5 divided by 2 squared, and this should give me x plus square root of 5 divided by 2 squared. That will now be a complete square, which will be very easy to solve. If I equate it to something, to solve it for x, I simply need to take square root from both sides and then solve a linear expression. Now that we know how to complete the square, how do we use this method to compute the roots of the quadratic equation? Suppose you have a quadratic equation. Let's say x squared plus 4x plus 3 is equal to 0. Solve this by completing the square. Solve by completing the square. So the first thing is I need to complete this square. I need to write this as a perfect square. X plus something squared. So first of all, this is x squared plus 4x is equal to minus 3. I've subtracted 3 from both sides. Then I need to add on the left hand side half of this. So I need to add b over 2a. Add b over 2a squared on both sides. The reason we add on both sides is so that we don't change the meaning of the expression. So we'll have this as x squared plus 4x plus, so 4 divided by 2 squared. I added this on both sides, so negative 3 plus 4 divided by 2 squared. But I know that this should be x plus 4 divided by 2 is 2, so x plus 2 squared should be equal to what we have up here, -3 plus 4 divided by 2 is 2, 2 squared is 4. So in other words, we have x plus 2 squared is equal to 1, which is very easy to solve. Take square root on both sides. So x squared plus 2 is plus or minus 1. Square root of 1 is plus or minus 1. Therefore, subtract on both sides. So x should be minus 2 plus or minus 1. So give you that x is either minus 2 minus 1 or x is minus 2 plus 1. So first we have that x is minus 3 or x is minus 1, where minus 1 is minus 2 plus 1. And you can verify that if I put minus 3 here, it should get a 0. If I put minus 1 here also, it should give me a 0. Let's try. So if you put minus 1 squared, no, this step is not necessary. I'm just trying to verify. Plus 4 times minus 1 plus 3. Let's see what we get. So we get 1 minus 4 plus 3. And effectively, this is 0 because 1 plus 3 is 4. 4 minus 4 gives you 0. How about minus 3? Put minus 3 squared plus 4 times minus 3 plus 3. Minus 3 squared is 9. 4 times 3 is 12. So minus 12 plus 3. And surely 9 plus 3 is 12. So 12 minus 12 gives you a 0. So it is true that minus 1 and minus 3 are roots of this equation. And this was a very nice example because we have been able to find two different zeros for this kind of quadratic expression by completing a square. One last example for completing the square. Solve by completing the square. So example 2, you want to solve now, let's say 2x squared plus, I don't know, 4x plus 7 is equal to 0. Solve by completing the square. We can so first of all, you can divide both sides by 2 so that you have coefficient of x squared as 1. So this is the same as x squared plus 2x plus 7 over 2 is 0. I've divided 2x squared by 2 to give me x squared, 4x by 2 to give me 2x, 7 by 2 to give me 7 halves. Then now I can write this as x squared plus 2x is equal to minus 7 divided by 2. By just subtracting 7 over 2 from both sides. Now the next step is to complete the square. On the left hand side, I need to be able to write this x squared plus 2x as x plus something squared. And we said to add simply half of the coefficient of the linear term. So I will need to add x squared plus 2x. For this, I need to add 2 divided by 2 squared, where 2 is this 2, coefficient of x. What you do on the left hand side, do on the right hand side. So minus 7 over 2 plus 2 divided by 2 squared. But we know that here over here, we will simply have x plus 1 squared is equal to, where the 1 is simply 2 divided by 2. That will give you what we have on the left hand side, should be equal to minus 3.5 plus 1. So this means x plus 1 square is minus 2.5. So minus 3.5 plus 1 is minus 2.5, which is the same as minus 5 divided by 2. Then to solve this, take square roots on both sides. So x plus 1 should give you plus or minus square root minus 5 divided by 2. This is beautiful, a very nice example. So that x is equal to minus 1 plus or minus square root of minus 5 divided by 2. Very quickly, you realize that you're going to have a complex root. You have done complex numbers. So you know that square root of -1 is simply I. So the solution for this is x is minus 1 plus square root of 5 divided by 2 I, or x is minus 1 minus square root of 5 divided by 2 I. And when you obtain complex roots for a quadratic equation, they will always be conjugates of each other. So you realize that The second root, which is -1 minus 5i, is the complex conjugate of -1 plus 5i. This was a very nice example. Let us look at now the quadratic formula. The quadratic formula. So 3 is quadratic formula. Quadratic formula. So in general, we are studying an equation of the form ax squared plus bx plus c is 0. We insist that a is not 0, because if a is 0, then we don't have a quadratic equation. We have a linear equation, which we have done before, and it's very easy to solve. So a must be different from 0, any number different from 0. By completing the square. So the method of completing the square, first we divide through by a, because it's not 0, so it makes sense to divide by a non-zero number. Plus b divided by ax is equal to minus c divided by a. So I've subtracted c, then I've divided by a. To complete square, we were dividing the coefficient of x by 2 and then adding the square of that, so that we will write this as x squared plus b divided by ax plus b divided by a, half of that squared. What you add on the left hand side, you must add on the right hand side for you to retain the meaning of your expression. Okay, but I know that the left hand side will be the same as x plus b divided by 2a squared, which must give me minus c divided by a plus b squared divided by 4a squared. So b over 2a squared is b squared plus 4a squared. I can combine this. The LCM is 4a squared. So a into 4a, that's 4ac plus b squared, because 4a squared goes into 4a squared once. So we're having this x plus b divided by 2a squared gives you b squared minus 4ac divided by 4a squared. We have a perfect square on the left hand side. So to solve, find square root of both sides. So square root of the left hand side is x plus b divided by 2a. On the right hand side, we have plus or minus square root of b squared minus 4ac divided by 4a squared. We know that the square root of a fraction is simply fraction of the square roots of what are inside. So we'll have x plus b divided by 2ab plus or minus square root of b squared minus 4ac square root of the numerator. Square root of our numerator, 4a squared, is simply 2a, because you can write 4a squared as 2 times a, all of that squared. So it means square root of this guy is simply what is under the root. Then you have x is minus b divided by 2a plus or minus square root b squared minus 4ac divided by 2a. And this can be combined to give you minus b plus or minus square root of b squared plus 4ac divided by 2a. And in the formula, you can see why we are insisting that a must be different from 0, because if you add a 0 here, then this solution will blow up. You get infinite values which are not very useful or interesting. So all you need to remember is that to solve a quadratic equation in the form ax squared plus b, then the roots are simply x plus, so x is minus b plus or minus square root of b squared minus 4ac divided by 2a. And because this is plus or minus, we get 2 roots in some cases. In some cases, you get 2 roots. In some cases, you get repeated roots. Okay, so let me take an example. Using the quadratic formula, for example, solve. You can even look at some examples we've done before. X squared plus 6x plus 9 is 0. Solved by quadratic formula. So in this case, a is 1, b is 6, C is 9. The formula says x is minus b plus or minus b squared minus 4c divided by 2. Let's substitute directly. So x is minus 6 plus or minus square root of 6 squared minus 4 times 1 times 9, all of that divided by 2 times 1, which gives you minus 6 plus or minus square root of 6 squared is 36. 4 times 1 is 4. 4 times 9 is 36. All of that divided by 2. 2 times 1 is 2. So this gives you minus 6 plus or minus 0 equals 36 minus 36 is 0. So square root of 0 is 0. Divide this by 2. So you get minus 6 divided by 2 is minus 3. So here either x is minus 3 or x is minus 3, which you can confirm from our previous solution of this by factorization. Okay. Another example. So that's first example. Second example. Solve 2x squared plus 5x minus 20 is equal to 0 by quadratic formula. Quadratic formula. So straight away, a is 2, b is 5, c is minus 20. So this means x is going to be minus 5 plus or minus square root of 5 squared minus 4 times 2 times minus 20. All of that divided by 2 times 2, which gives minus 5 plus or minus square root of, so 5 squared is 25, 4 times 2 is 8, 8 times minus 20 is 160. So 160 plus 25, 160 plus 25 gives you 185, all this divided by 4. So here we will get two answers, so minus 5 plus square root of 185 divided by 4, minus 5 minus square root of 185 divided by 4. You can go ahead and simplify, or simply leave the expression as this. Like that. You can use a calculator and find the exact values. Now that we have known how to solve quadratic equations by factorization, completing the square, and the formula, of course, the formula comes from completing the square. From this formula, we can be able to predict the number of solutions that a quadratic equation will have without necessarily solving. Now this brings us to the idea of a discriminant. What is a discriminant and how can we use it to tell whether a quadratic equation will have roots or will not have roots? If it will have, how many? Maybe 2, or will it be 1 that is repeated? So from the formula, solving ax squared plus bx plus c is 0, where a is not 0, we have that x is minus b plus or minus square root b squared minus 4ac divided by 2a. This term that is inside the bracket is what we call discriminant. So let d be b squared minus 4ac. And then d is called the discriminant. Discriminant. So let's call this E of equation E. D is the discriminant of equation E. And from this discriminant, we can be able to tell, without necessarily solving the equation, how many solutions will it have? Will it have real solutions? Will they be repeated? Or will they be different, depending on the sign of this guy? So some notes, if D is positive, then E has 2 distinct real solutions, which means the solutions are different from each other. For example, there's an example where I gave you that the equation has -1 and -3 as roots. So -1 and -3 are different. That is what we mean by distinct. That's number one. Number two, if D is 0, then E has one repeated root. For example, x squared plus 6x plus 9, you're getting x is -3 or -3. That's an example of an equation with repeated roots. And lastly, if D is negative, is less than 0, so you're taking the square root of a negative number, you get complex roots. Then E has no real solutions. The roots will be complex because we're taking the square root of a complex number. So example, suppose you have x squared plus 6x plus 9 is 0. Find the discriminant of this. So part A, find the discriminant. We define D as a squared minus 4ac. In this case, a is 1, b is 6, c is 9. So the discriminant will be 6 squared minus 4 times 1 times 9, which is 36 minus 36, and that is 0. Part 2, how many real solutions can be obtained? So we're using the discriminant. We know that if the discriminant is 0, we are told that it has only one repeated root. So by the property, we know that you can only get one root. Then the third part of the equation is find the roots. Find the roots, if any. So the formula is that x is minus 6 plus or minus square root of 6 squared minus 4 times 1 times 9 divided by 2. So this will give me minus 6 plus or minus 0 divided by 2, which is minus 3. So this will have repeated roots, and the repeated root is minus 3, which is a real number. Let me give another example. Another example, suppose you have 2x squared plus 5x minus 7 is equal to 0. Find the discriminant. So part A, find the discriminant. We have defined discriminant as b squared minus 4ac. So in this case, a is 2, b is 5, c is minus 7. So this should be 5 squared minus 4 times 2 times minus 7, which is 25, plus 8 times 7 is 56. It should give you 81. 6 plus 25 gives 81, which is greater than 0. So by the discriminant, this equation, let me call it E2. E2 has two distinct roots. I can tell that because D is positive, the discriminant is positive. You'll have two distinct real solutions. Then part C, what are the roots? What are the roots? So the roots will be by the formula, x is minus 5 plus or minus square root of the discriminant, which is 81, divided by 2 times 2, that's 4. So this will give me minus 5 plus or minus 9 divided by 4, where 9 is square root of 81. This gives me either minus 5 plus 9 divided by 4 or minus 5 minus 9 divided by 4. So you have that either x is minus 5 plus 9 is simply 4. 4 divided by 4, that's 1. Or x is minus 5 minus 9, that's minus 14 divided by 4, that is minus 7 halves. So this will be the two distinct roots of the equation 2x squared plus 5x minus 7 is equal to 0. Let me give an equation that does not have a real root. Equation that does not have a real root, where you've seen one before. So suppose you have the equation, let's see, x squared plus, I don't know, plus x plus maybe, let's say, plus 6 is equal to 0. So part A, the discriminant. So let me call this E3. The discriminant of E3 is given by D is A squared minus 4AC. B is 1. So you have A is 1, B is 1, C is 6. So you take 1 squared minus 4 times 1 times 6. That is 1 minus 24, which is minus 23. Discriminant is negative, so you will not have any real roots. And in such cases, the roots exist as conjugate pairs. So part B, no real solutions, stroke roots, because D is negative. Now part C, the roots will be minus 1 plus or minus square root of minus 23 divided by 2, which will give you x is minus 1 plus 23i divided by 2, or x is minus 1 minus 3i divided by 2. This will be the roots of this equation. So it is possible that you can find the number of solutions that a quadratic equation will have without necessarily solving the equation by computing what we call discriminant. It's very simple to compute. If you have an expression ax squared plus bx plus c is 0, where a is non-zero, discriminant is simply b squared minus 4ac. Depending on the sign of this number called the discriminant, you can tell how many solutions, real or how many real solutions an equation will have. So if it is 0, you have only one real solution, which is repeated twice. If it is positive, you will have 2 distinct roots. And if it is negative, you will have complex roots, which are not real solutions. There are so many applications of quadratic equations because most of these functions that are used in real life are of degree 2. So you end up a problem solving roots of quadratic equation. For example, I can think of a projectile that is launched, especially if you are in the forces. When you're launching a projectile at some angle, those who did physics, you are familiar with S is a half AT squared plus 2as plus maybe k. I'm not sure of this, but because plus 2at. So this t, this is a degree 2. So to solve this, I will need to know how to solve quadratic equation. So I will treat this as the coefficient of the high degree term, coefficient of the linear term, and the constant term. So let me give an example. For example, suppose a room is 1 meter longer than it is wide. And area 9 square meters. And the dimensions of the room. And the dimensions of the room. Okay. So as usual, let x be the length of the room. We've been told it is 1 meter longer than its wide. That means x minus 1 will be the width. How do you compute area? Area is simply length times width. In this case, length is x, width is x minus 1. We'll give the area as 29. So multiply out this, you get x squared minus x equal to 39, which is a quadratic equation. Very easy to solve. So write this as x squared minus x minus 29 is 0. So a is 1, b is minus 1, c is minus 29. Therefore, x should be, I'm using the formula, okay, 1 plus or minus square root of minus 1 squared minus 4 times 1 times minus 29 divided by 2, which gives me 1 plus or minus square root of 1 plus, so 29 by 4, that's 6, 3, so 8 is 116 divided by 2. Therefore, the solution will be 1 plus square root of 117 divided by 2, or 1 minus square root of 117 divided by 2. Clearly, this second term is a negative, and length cannot be a negative. So we will ignore this and take the first term. You cannot have a negative length. So that means the length of this room will be root of 1 plus, 1 plus square root of 117, half of that. And then the width will be, so this, you subtract 1 from this. So in other words, the length is going to be 1 plus square root of 117 divided by 2. Width is going to be 1 plus square root of 117 divided by 2 minus 1, which is going to be simply square root of 117 minus 1 divided by 2. So this should be the dimensions. This is the length, this is the width. That marks the end of the topic quadratic equations. So we have defined a quadratic equation from as a polynomial of degree 2. So from the expression, when you introduce an equal sign, you get an equation. Then we have looked at 3 methods. So the method of factorization, factorize the left-hand side, and then use the property of real numbers, that the product of real numbers can only be 0 if one of them is 0. That's factorization. The second method that we looked at is completing the square, so that we are able to write one side of the equation as a complete square, so that solving a complete square is simple because you simplify square root on both sides and then end up with linear equations, which are very easy to solve. And lastly, we have looked at the method which is derived from the completing the square method. Thank you.